This code has a bug, a nasty bug. Can you see it? If not, don't feel bad. I couldn't see it either. I pushed this bug to production a few years back, made my customers pretty unhappy with me. This is my Stripe controller. It receives webhook notifications from my payment processor, Stripe. This routine here goes off when a customer's subscription payment is received, allowing them access to my site. When I pushed this bug, things started failing. My customers lost access and got cranky, no doubt losing trust in my ability to code the most basic things. Stripe sent me a nastygram telling me to fix the bug or they would disable everything. So where is it? Have you seen it? It's right here. It's kind of hard to see. Have you seen it yet? That line needs to be up there. Why is that? Because I'm setting this variable here and using it there. Nice one, Rob. How did this bug make it to production? Because I didn't have any tests for this routine. Now I know to write tests. I've been writing code for 20 plus years. When you ask people why they don't write tests for their application or why they skipped writing tests for a certain function or feature, they will often tell you the primary excuse, which is that they just didn't have time. They had to ship that code. Other people might say, well, you know what? Tests are more code. I'd rather do something different, like using my own test script that I write myself and click through the application to make sure that it works. And yet another excuse might be, well, I just don't know how to use this test framework right, and I don't want to write bad tests because then I'll just be writing a bunch of code that I'll have to maintain and it'll break later on. I just don't want to deal with that. So let's just start right there. Let's win the first battle, which is just to write any tests at all. How can we speed up the testing process? Well, if I hit Command-Shift-P or Control-Shift-P on Windows and I type in snippets, we can go to Configure Snippets and then pick your language here. I'm going to do JavaScript because I'm using Mocha. These are my JavaScript snippets. As you can see, I like to log things out to the screen. Old school. But here, if I want to write a test, I just use its or ITT for just doing a test stub. That makes things insanely simple. But that is not all. If I come over to extensions and type in Mocha and I just type snip, you can see there are a ton of snippets in here. We have Mocha snippets using ES6 and others. Anyway, I have a whole bunch of these things. So when I want to write a test, I will just hit DESC for describe. This is the Mocha describe block. And then I hit tab. That'll do the autocomplete. And then I can just put a test. And then if I tab down, my snippet is ready to go. And I could say it. And this is going to be my test stub. So I will just type stuff here, escape, save, and we're good to go. There we go. Just that fast. I was able to write a test. Let's see what else we can do to speed up the testing process. Here you can see I have some sample code, shopping cart. The simplest thing that I can do right now is to use some form of test generator. And the best test generator that I know of is GitHub Copilot or some form of AI. So what I'm going to do is I am going to use what's called a chat participant. And I'm going to say, hey, workspace, create tests for this using Mocha and assert, because I like to use assert. Some people like to use chai. Again, I'm using node. And so what Copilot's going to do is it's going to take a look at all of the files that we have in the project, and it is going to write a set of tests for us to at least get started. So let's open up our shopping cart tests. There we are. And what I'm going to do is I'm going to scroll down and pop that in. Boom. That's great. Our goal is achieved. We have some tests. We are winning. Having any tests at all is a good thing. Let's take a look at the third thing that can speed this up dramatically. So because I'm using Mocha.js and I also have an extension installed, let's take a look at this. I can say Mocha test, and I have this extension installed right there. Mocha runs Mocha tests. Boom. So it's installed, and what this does is it interacts with the test explorer, which is this right here. And so whenever it sees these tests, it'll give us the test runner ability, meaning we can run, debug, show, and test explorer, and so on. So if I hit go, boom. Believe it or not, all these tests pass. Now, are these ideal tests? Will they always pass the first time? Well, Copilot is doing its best. It might not get it right the very first time, which is okay, because these are here just to get us off the ground. In fact, if we have to do any tweaking at all, we can come up here and use enable auto run. And that's where things get fun, because you can see these little checks right here. If we want to add a test or change anything, we don't have to keep running things. For instance, I can come down here and hit 1. The minute I save a file, boom, the test is rerun, which is neat. And it says expecting things to be equal. If I hover over it, it'll give me the answer. So let's go back and fix this. I'll hit 0 and we pass. So using those three things, snippets, a test generator like Copilot, and the test explorer, we have just sped things up. And then we turned on auto run and we are off to the races. Writing a good test is just like writing good code or clean code. It's a skill you need to develop over time, but it's a skill absolutely worth building. Let's take a look at what a good test looks like. Let's see how we can write a better test. Now, I am well aware that everyone has an opinion on what a good test looks like. If you disagree with me, that's great. Leave a comment. Tell me what you disagree with, because then we can all learn. Okay, so how could we write a better test? Well, this involves coming in here and reading over what we have. Shopping cart should start with an empty cart. Should add items to the cart. Well, I'll just stop there. The way these tests are worded doesn't necessarily make sense. In addition, if we come down over here, should start with an empty cart, we can see a count is 0 and a subtotal is 0. Is that a good thing? Well, for a lot of testers, people don't like to see two assertions in a single test. And the reason is because we're actually testing two things. We're testing that the count method works and also the subtotal method works. All right. So we should split those things out. Should add items to the cart. What should add items to the cart? The shopping cart? Not really. So we can reword this test so it makes more sense. Let's do that now. I'm going to go through here and do a refactoring step. I'm not going to make you watch me write all the code. I'm simply going to come in here and refactor this, and then we'll talk about the difference. There you go. You can see we have quite a few more tests. And the reason is that once you start refactoring things for naming, then you start to think, well, wait a minute. What happens if I do this? What happens if I do that? For instance, we didn't have anything for the initial state of the cart. We just started by adding things. So I added that. What's the initial state of the cart? Well, there are no items in it. And the subtotal is 0. That seems reasonable. What if we add one? Well, then there's one item. The assertions match the description of the test. That is what a nice, clear test looks like. Now, you might be thinking, that's not how I write tests, Rob, and that's totally fine, as long as you write tests. And if they're clear to you and clear to your team, that is great. What you want to do is you want to make sure that every test you write has an assertion that at least matches the description in some way, shape, or form. Okay, let's go back up here to this naming. What is the happy path? What does that mean? Well, the happy path is when everything works the way you expect it to. In other words, when everything is just going the right way, the cart should respond by allowing people to add and remove items. That makes sense, doesn't it? The idea is that you always want the happy path to be passing. That means that, well, things are working as they should. Then you start going down the sad path. What happens if we get a customer that starts messing with us? What happens if somehow they figure out how to add null? Or maybe they have figured out how to add a negative item by hacking into the console online and putting a quantity of -5. I've seen that happen before. What do we do about that? Well, we add more tests. In fact, we're at the point now where we can say, what if, what if, what if? Now, before I get there, notice that you can nest these test blocks. I like to do that because when we have a bunch of tests, we're going to want to be able to collapse and then expand as we need. So the shopping cart happy path, you can see we have 5 separate contexts of the happy path. We might want to add more later on, including right now. So what I'm going to do is I'm going to come up here and I'm going to do this, and I'm going to come down here and do another describe block. Thank you, Copilot. I don't know how it knew I was going to put sad path, but it did. So we could do sad path, but that's not exactly what I'm looking for here. I want something more declarative, something that's clearer so we can understand. How about someone messing with us? Something like that. The reason I put that is because that's pretty much the one vector I'm thinking about. How would we get bad data in here? There could be a number of ways. Maybe we have bad data. Here's another one. We could have some bad data in the database. That could come in the form of a dirty read or an index that is off, a bad query that we wrote, something like that. Anyway, you can keep adding these ideas in here to fill out the test. In fact, let's fill out a few, such as adding null. Let's do this. I'm going to do a describe block here, and I'm going to say adding null. Let's see if Copilot can figure this out. It throws an error. This is very nice. Cart.add, please pass a product. Okay, let's run this and see if it works. Indeed. How did Copilot know that? Because the shopping cart is open in here, and as you can see, we have a check for that, which is good. Okay, so it throws an error. That's adding null. What are some of the other things we can think about? How about we can describe... It does not add the item. Very good. All right, so we've got -1, and then we've cart count equal to 0. So let's run this, and good. And again, we have the code for that already, where we check to be sure if we go into add, if the quantity is less than or equal to 0, that we return. So as you can see, when you think about what it is you're asserting and writing clearer tests, then the next test, the follow-on test, becomes simpler and easier to write. We have a nice clear description here, and our assertions are starting to make sense. Let's talk about the actual structure of a test really quickly. There are a number of ways you can do this. I'm going to show you the first one that I like to use for unit tests and that I think is pretty standard. We're going to talk about other ones later on when we start talking about behavior. However, as you can see here, when you're working with Mocha and most JavaScript testing frameworks, you think in terms of blocks. We have a describe block on the very outside and then inner describe block. And inside of that, we have a few other blocks. And as you can see, before I run any tests inside of a block, I have a before. I can do a before, which is going to run once for this entire block, or I can do a before each, which will run before every test inside this block. This is important to know. Now, I like to write tests with just one arrangement, because then what you can do is you can arrange, as you can see here, the data that you're going to be working with inside that test block. So I'll be working with a cart inside here, and we're going to just new it up, and then we're going to add a product. And I'm only going to do that once, because every assertion down below, as you can see, is going to assert against that block. And that's that. Arrange, act, assert. You're going to hear this a lot. So it's a good idea to have a before block of some kind, so every test can be as slim and easily changed as possible. And here you can see my tests are simply just an assertion, and that's that. There's nothing else that needs to happen. As you can see, writing tests is actually fun. At least I think so. Once you build that skill, well, it becomes fun to kind of break things, I think. You know what's even more fun? Not breaking the build. That's more fun. And you know what's even more fun than that? Not bringing down production because you shipped a critical bug. So some developers have so much fun writing tests, they actually write tests first because they believe in writing tests that help them build a better, cleaner architecture. Let's see how. And before I get going, I will say that test-driven development, or TDD, that's not what I'm going to be doing here. I'm just going to be writing tests first. Now, TDD is a volatile topic. If you have an opinion about it or what I'm doing, please add to the discussion below. We can all benefit. All right, let's see how we can now write tests first. Now, as you notice, I have just an empty test file here. I've deleted all my tests. In fact, I don't even have my class over here. So what I'm going to do is I'm just going to start right here, and I'm going to describe the shopping cart, because that's all I really know that I'm building. I have a spec, let's say, that's next to me, and a shopping cart idea. And so what I might do if I'm writing tests first is I might just say something like it, ITT, let's do that, it exists. So how do I take this out of pending state? Well, I don't have a shopping cart class to speak of or any functionality, so it's too easy to make it fail. That'd just be a runtime error. That doesn't make sense to me. So what I'm going to do is just right up here, right in the same file, shopping cart. And that's that. Now here's the trick. When you do test first, or TDD, you want to do the least possible thing to get a test to pass. So here, what I can do is just say assert new shopping cart. Boom, just like that. And this will pass. Now see this, well, would it pass if I did assert? And let's actually move this up here. There we go. Okay, so let's run that again. So that will pass. So that is not strict TDD because it's supposed to be red, green, refactor, and I'm not doing red, I'm just doing green. So we know that the cart exists. And what else might I want to do? Well, we might want to, of course, let's do, that's it, shopping cart.items. We want to make this as simple as possible. Boom, it's going to go red, and then we're going to do exactly that. Thank you. And then going to run this, and it passes. All right, let's keep rolling here. So here I'm going to do it's that. All right, so then from here, what we could do is we'll do that exactly right. We have a new shopping cart. We're going to push Apple. Actually, I'm going to make this even faster. I'm going to put, and there we go. I'm pushing a 0, and this test pass. Is that what we want? So this is where things get interesting. Now, ideally, in a test-driven development world, you're supposed to have a test invalidate or validate your assumptions about a class. And if we wanted to keep going down that strict way of thinking, then I would need a test at some point to say, hey, we should not be working with items directly. That is not how we should be doing things. That said, I think at this point I can skip ahead and say, you know what? I don't like this idea. How can we get around it? Well, instead of doing a class, what we might want to do is have this be a function. This right here is called the revealing module pattern. And the reason that people like it so much is it because one, it forms a closure, but two, it allows you to work with private variables, which in JavaScript, which is pretty neat. Okay, so now let's rerun this, and we still have a failing thing down here. We'll set that to 0, and that should pass, and it does. Good. It has items. That's all we know. All right, well, how can we fix this? Well, simplest thing we can do, again, is to add, and there we go. Now I'm exporting count and add. Good. All right, let's rerun this now, and now our test pass. All right, I will stop here. Hopefully you can see the different mental processes you go through when you write test first, and you play the little game of challenging yourself to do the least possible thing and to actually try and destroy your other tests as you go along. This process of failure and refactoring and failure and refactoring, well, that's what writing tests first is all about. And to be honest, I like this code better than what I had before. I like that we're hiding the items back here so they can't be manipulated by external code. I think that's pretty neat. We have a bunch of lovely unit tests over here that we really like. We have our happy path. We have our sad path down here that we're starting to build out. We're happy. There are a lot of tests, but has this ever happened to you when your lead comes in and says, refactor this to be a sales order instead of a shopping cart? There we are. We have an order item and a sales order because basically that's what a shopping cart is. It is a customer coming in saying, "Hey, I want to buy stuff. Here's my here's my order." Yeah. So we refactored the name, and then our lead was like, "You know what? I want this to be called item count and add item and then remove item." You get where I'm going. Code reviews are so much fun. Let's go back and refresh our tests, and you can see Mocha immediately bombs. Everything broke just because of a rename and a refactor. And this is one of the problems when you end up with a bunch of unit tests. Changing can be hard. However, there's a different way to go about this. We can write tests that don't just go after functionality like unit tests do, but actually describe the behavior of someone using the application. And this is called behavior-driven design, or BDD. And to be honest with you, this is one of my favorite things. I love working with it. So let's see how we can change our test now. And I'm going to go back once again, like I do, and I am going to refactor out of here. And I'm going to start from the very, very beginning. And as you can see, I've refactored my tests as well as my code. And it can take a while to get used to this. And I will say behavior-driven development is pretty exacting. And it does take a while to pick it up. But when you do, you end up with some really fascinating tests. In fact, I will say these aren't actually tests. They are referred to in the BDD world as specs, specifications. You might think that's strange, but when you look at this and the way this is structured, and I'll go into that in a second, these actually look like specifications you could pull off of a spec sheet. And that is the way they are referred to in the BDD world. Executable specifications. And they have a structure to them, as you can see. And let's step through this really quickly, because as I mentioned, it does take a while to get used to this, and it can be overwhelming. But if you stick with me, maybe you'll pick a few things up. First, when you write behavior-driven design, you're talking about your application's behavior. And behavior is only dictated from the customer's perspective or the user's perspective. When they click a button or when they do a thing, how does the application behave? That is our thing that we're focusing on. We're not focusing on individual functionality of a function. That is going to make our tests much easier to change as we go along. For instance, if we rename something, then all we got to do is come in here and change just the implementation stuff. We don't need to actually remove or delete any one of these tests, which I think is neat. So speaking of, let's take a quick look at the structure of behavior-driven design. From the outside here, we have a describe block. And as you can see, I'm using multiple describe blocks. They're all nested. But we have a feature. Feature has multiple scenarios, and then each scenario has some specifications that we execute. So on the outside here, what we're talking about is the customer order lifecycle. When they come to the application, what are they going to be doing? Well, we need to narrow that down a little bit more. So let's come up with some scenarios. Let's say this is their very first visit. We have a few other scenarios. Maybe we have, as you can see down below here, we have a returning customer, but they've never bought anything from us. Or maybe they have a high lifetime value. They're very valued to us. Will the application change in those cases? So you can think through now. We can narrow things down in terms of scenarios. So once we have a scenario in place, we go through this dance called given, when, then. I'll collapse this right here. Given basically is kind of like a range. Given we have a new customer with a new order, right? That's fine. So we have right here in our before block a brand new customer with a brand new order. Good. Then we want to describe the result when something happens. Given, when, and then. The order is empty, their subtotal is 0, right? So given we have a new customer with a new order, great. When the session starts, their order is empty and the subtotal is 0. Good. So given that they want to buy something here, then what happens? So we can come down here when they choose, and here we go. We act on this data. Then their order has 1 item, and then their subtotal is 100. So this is probably not strict BDD. We could have some people in the comments quibble about this, which is fine. I think as long as your head is in this space when you're thinking about the specification for a feature and you think about different scenarios for a given specification, what happens when I do this? What happens when I do that? What happens if we have a bad actor come in here and start messing around? That could be one of our scenarios. And then we can build out our tests from there. All right, that is behavior-driven design. So there you have it. Create some snippets for your tests, ask Copilot for some help, stop breaking the build, stop bringing down production. You'll sleep better at night and you'll feel better about covering your code and uncovering those bugs that will cause problems and make you feel embarrassed. Eventually, if you keep writing solid tests, people will start coming to you for advice and then you can pass it on. Getting help from Copilot is so useful when testing. And as a matter of fact, that prompt that I showed you when I was writing those tests, well, I didn't learn that on my own, and it is critical to learn your prompts. If you're going to be using Copilot for things like this, you want to be able to write good tests. Now, if you want to learn some secrets to prompting, you will want to be sure you watch this video right here. That's my colleague, Burke Holland, giving a masterclass in essential prompting skills. All right, that's it for me. Thanks for watching, and happy testing and happy coding.